Hey kiddos, it's Miss Taylor. Today we're going to be going over Monday and Tuesday's assignment. Today you will be learning about two types of waves. So the first type is called mechanical, and the second type is called electromagnetic. If you look at the front cover of your assignment, you're going to be using the PowerPoint to complete the fill in the blank, and after that you have a few assignments that you're going to be working on. They're basically going to be on your vocabulary, labeling parts of the wave, classifying waves, and then finding the velocity of a wave. Alright, so let's go ahead and take a look at the first section of your PowerPoint. So we're going to be talking about waves. So before we begin, let's go ahead and define what waves are. Waves are actually an oscillation, which is basically a movement that is either from left to right or up and down, and they usually travel from one place to another with a certain velocity. So velocity is usually distance over time. Okay? Today you will be learning about two different types of waves, their characteristics and behavior. The first type is called mechanical, the second type is called electromagnetic wave. Now, with every wave, there are certain particles or certain characteristics you need to know. For example, you have the amplitude, the wave, the frequency, the hertz, and the speed. All right. So when you look at a wave, you're going to have the amplitude. The amplitude is usually from the resting area to the top of the wave. So usually that's called the amplitude. And the second part you need to remember is the wavelength. So if you're looking at the top of a wave to another top of the wave, that would be the wavelength. Or if you're looking from the section of the middle to the other section. Now notice that I'm not going from here to here because that's not a full wave. This wave is going down and you're going to have to look for the wave that goes down with it. Okay, so you're going to be looking on that side. The same parts here. Frequency is the number of times it produces an amount of frequency. So basically, how many times does it touch here? Hertz is frequency of a wave is measured. So how many times did it go up and down within a certain amount of time? Wave speed, usually how fast it's going. It travels in a given amount of waves in a certain amount of time through a certain medium. Now we're going to be using mediums as a reference as to types of wave. Is it a wave in a slinky? Is it a wave in a piece of rope? An ocean wave? A radio frequency wave? Stuff like that. Okay. And if you notice, there are some links here. So if you do have Wi-Fi, I would suggest to look at these videos here. So let's go ahead and talk about the first type of wave. The first type of wave is called mechanical wave, and that usually travels through matter. So matter is usually a solid, liquid, or gas. Sound wave is an example of mechanical wave. Mechanical wave are incapable of traveling through empty space. So it has to travel through one of these types of matter, okay? For example, if I have a slinky and I transmit energy from one end to the other, that would be considered a mechanical wave. The same thing with a jump rope. But remember, mechanical waves have to have their own medium. So if I'm looking at a slinky, I need coils. If I'm looking at water waves, I need water. And if I'm looking at a jump rope, I need a rope. Now the second part here, the second type of wave I'm looking at is called electromagnetic waves. Electromagnetic waves actually travel through empty space, and these are the type of waves that we cannot see, but we know it's there. So usually electromagnetic waves are produced by vibration or charged particles. The sunlight is an example of electromagnetic wave, and any type of light. So I have gamma rays, X-rays, ultraviolet, infrared, microwaves, radio waves, and then even just visible light itself. So what do electromagnetic lights or electromagnetic waves look like? So we usually use a spectrum for electromagnetic waves. Usually the most radioreactive is on the right, and those are called the gamma rays, the X-rays, and the ultra waves. So even though they're very radioactive, they give off a lot of radiation, and they usually have more energy. Okay, but they usually have shorter wavelength. If you're looking on the left side, you have radio waves, microwave, infrared, and they're usually longer wavelengths, but they have low energy. So they're very limited. And then right in the middle is called visible light. Okay? And if you look at the bottom of these, this is how far they can go. Alright? I don't have anything else on electromagnetic waves or mechanical waves, so I'm going to go ahead and go over your expectation and your assignment. So these are actually your fill in the blank, your notes, and one of the reasons why I included them was because, you know, I'm not going to give you that face-to-face interaction. So it's going to be good for you to go through and fill these in on your own. So I have all the slides numbered for you. And I even have a little bit of a small electromagnetic spectrum for you to fill in. On this side I have an assignment. It's about the vocabulary. And then at the bottom you're going to be labeling parts of the wave. On this section here, you're going to be classifying the waves into two categories, and you're going to be drawing the electromagnetic spectrum for me. So if you have any questions, just go ahead and give me a call or shoot me an email, and I'll go ahead and respond to you. All right? Have a good day. Bye.